It's been called the most dangerous volcano in the world, a ticking time bomb and an angry beast. But according to a recent press release, it might also be broken. Is this the end of the world as we know it? Or is something else going on here? Let's dig into what exactly is happening at Yellowstone. Yellowstone National Park straddles the northwest corner of Wyoming and small portions of Montana and Idaho. It's famous for its geothermal features such as Old Faithful, which is pretty impressive. But the real star of the show is the magma chamber beneath the park. That's because Yellowstone sits atop a supervolcano, one of only a few in the world. And these special volcanoes are truly awe-inspiring in both their beauty and their danger. A supervolcano is any volcano that has had an eruption with a volcanic explosivity index, or VEI, of 8, meaning it blows more than 1,000 cubic kilometers of material. To put that into perspective, Mount St. Helens, one of the most dangerous volcanoes in the contiguous US, has a VEI of 5. So there are 5 levels of volcano above a supervolcano. Also, the largest known eruption in Earth history was at a supervolcano in Indonesia, and it had a VEI of 8. This eruption unleashed over 2,800 cubic kilometers of ash, pumice, and other volcanic debris, nearly 30 times the volume of the asteroid that killed the dinosaurs. So needless to say, the consequences of a supereruption could be devastating. And unlike Mount St. Helens or Mount Vesuvius, whose eruptions were relatively quick and contained, the Yellowstone supervolcano's eruptions are much slower. Instead of blowing all their steam in one shot, they do it over several days or even weeks. The reason for this is the magma itself. Unlike your typical magma, which has a silica content around 52 to 62%, the magma in Yellowstone is much more viscous, ranging from 70 to 80% silica. Think of it like honey versus corn syrup. Honey is less viscous, flows more easily, and erupts out of the volcano faster. Corn syrup takes more time to ooze out of the volcano. So when it comes to predicting how long a volcanic eruption will last, the silica content of the magma is key. The worst part is that it's really hard to predict when a supervolcano will erupt. Scientists use lots of different tools to monitor active volcanoes. For instance, at Mount Vesuvius in Italy, scientists can measure small earthquakes known as microseisms coming from the volcano. Microseismic activity increases before an eruption because of the movement of magma and gases beneath the surface. But at Yellowstone, microseismic activity doesn't necessarily correspond to magma movement. There have been years of intense seismic activity followed by quiet periods and vice versa, so measuring earthquakes alone won't tell us much. Another way scientists keep tabs on volcanoes is by looking at ground deformation. Again, at Mount Vesuvius, they've noticed that before an eruption, the ground above the magma chamber swells. But at Yellowstone, it's a little more complicated. You see, there's not just one magma chamber, but 3 stacked on top of each other. The deepest one is 6 kilometers beneath the park, and the top one is 9 kilometers away. They're all connected, but they don't always do what you'd expect. Sometimes the magma chambers expand and sometimes they shrink, and it's not clear why. Sometimes the ground above the magma chambers rises and sometimes it falls without warning. So keeping track of the shape of the land is no better at predicting eruptions than listening for rumblings below the surface. Finally, scientists can also study the gases coming from a volcano. As magma ascends through the Earth's crust, it releases gases that make their way into the surrounding rocks and eventually escape at the surface. By studying these gases, scientists can get an idea of what kind of magma is beneath the surface. In the case of Yellowstone, researchers can measure carbon dioxide, hydrogen sulfide, methane, nitrogen, and even tiny amounts of sulfur dioxide. All these measurements help paint a picture of what's happening beneath the surface. But even still, it's far from perfect. One problem is that some of these gases also come from non-magmatic sources such as geothermal heat or decaying organic matter. So, you have to carefully rule out those possibilities before you can attribute an increase in gas emissions to magmatic activity. Another problem is that while the amount of gas spewing from the park does fluctuate, that alone isn't enough to predict an eruption. Researchers need to know the exact chemical composition of the gases, and that requires direct sampling, which isn't easy to do. So after all this, You might be wondering, do we actually know if the Yellowstone Supervolcano will blow anytime soon? And the answer is, we don't. The best we can do is look at past eruptions and see how often they happen. The Yellowstone Supervolcano has had 3 major eruptions in the past 2 million years, roughly every 640,000 years. So if we go by averages, the next eruption should be in about 360,000 years. But that's just an average. The actual time between eruptions could be anywhere from 100,000 to 2 million years. Basically anything could happen at any time. So with so many unknowns, it's not surprising that people are constantly worrying about a super eruption at Yellowstone. So is it actually overdue? Well, maybe. But in reality, it's impossible to say. Not only are our measurement tools imperfect, but the system is also chaotic. Just think of the weather. Every day the atmosphere is in motion, and scientists work tirelessly to improve their models and make better predictions. But even with all their advancements, meteorologists can only predict the weather for a week or so into the future. Beyond that, the system becomes too chaotic and the margin of error too great. Something similar is happening beneath Yellowstone. We can collect data and run models, but there are just too many variables. We don't know enough about the magma chambers, the plumbing system, or the magma itself to make accurate predictions. This brings us back to the recent press release claiming that Yellowstone Supervolcano is broken. What does that even mean? Well, in 2021, a team of researchers published a paper suggesting that there had been a change in the magma plumbing system below Yellowstone. They came to this conclusion because the composition of magma that was erupting at the surface had changed. Over the course of the last 15,000 years, magma from the deepest magma chamber had made its way up through the middle one and then erupted at the surface. This new magma was less silica and more iron and magnesium rich than the magma that had been erupting before. It was basically recycling through the system and changing its chemical composition. But in the last 2 years, the magma in the middle chamber seems to have solidified, creating a blockage in the plumbing system. This would explain why we haven't seen magma from the deep magma chamber reach the surface recently. So, in a sense, the system might be broken, but it's not because of a lack of magma. In fact, there may be even more magma now than before. Instead, it's because of changes in the chemical composition of the magma. Even though the plumbing system might be clogged, there's still plenty of magma in the deep magma chamber, meaning there's fuel for another super eruption. If this is true, then Yellowstone could be considered more dangerous than ever. After all, we have no idea when the plumbing might clear and magma could start flowing again. But let's step back for a second. When talking about the danger of Yellowstone, it's important to remember that there's nothing new under the sun. Every volcano in the world was once dormant and then became active again. Right now, the Yellowstone Supervolcano is in an intereruptive period. It's calm and everything seems fine. But at some point, the magma will start moving again. It will find a new pathway to the surface and a new eruption will begin. This is the cycle of life for a volcano, and we are very lucky that it happened to form in the middle of a national park instead of a densely populated area. The truth is, Yellowstone will erupt again. It's just a question of when. So, rather than worrying about whether it might erupt tomorrow, we should be grateful that it hasn't erupted today. Speaking of things that are hot right now, thanks for watching this episode of SCI Show. If you want to help us keep making good science videos, you can join our community on a crowdfunding platform. With your support, we can continue exploring the weird, wild world around us, and we can even make some neat perks like blooper reels. You can find out more on our crowdfunding platform page.